We have a problem here we have to integrate. We're given the integral of theta squared sine 2 theta d theta. And we have the formula for integration by parts here. The integral of u dv equals uv minus the integral of v du. We have our u as theta squared, our dv as sine 2 theta d theta. Because it's easier to differentiate theta squared, it goes away to 0. And this we can integrate easily. Now, one thing to keep in mind for this problem, the tabular method is much better. Because if we integrate this, we're going to have to do it repeatedly. And it's going to be cumbersome. So I'm going to show tabular integration and how it makes this problem a lot easier. The method of tabular integration has us list u of theta and its derivatives, v of theta and its integrals. So u of theta we've identified as theta squared, v of theta sine 2 theta, we're going to leave the d theta out. So what is the derivative of theta squared? With respect to theta is simply 2 theta. Derivative of this, again, it's 2, derivative 0. What is the integral of sine of 2 theta with respect to theta? It's negative cosine of 2 theta divided by the derivative of that with respect to theta, which is 2. Now, what is the integral of this again? Well, integral of cosine is sine, so that's going to give us a negative sine of 2 theta. Then we divide by the derivative of this, which is 2, so that becomes 1/4. Integrate this one more time. We have the derivative of sine is negative cosine. So now with this negative, it becomes a positive cosine of 2 theta. Divide by the derivative of this. So this becomes 1/8, positive 1/8. According to the rule of tabular integration, we're simply going to take this first derivative, draw an arrow to the second, technically the first integral. The second in the row of integrals, it's the first integral. Draw another from this, and then another like this. There's no point drawing an arrow from 0 to here because what we're going to do is multiply here. We're going to multiply, and obviously we don't have to multiply 0 by anything. The first one here, we have a plus on it. The second, a minus. The third, a plus. The signs would change. So the signs alternate. So keeping in mind what I just erased, if we put it all together, we simply multiply what was on the left side by what was on the right-hand side, according to the arrow. Going with the arrows, that's going to leave us with negative 1/2 theta squared cosine 2 theta plus 1/2 theta sine 2 theta plus 1/4 cosine 2 theta plus c. Now, since this is a definite integral, we're going to have to find an exact answer. So we can't simply leave this with our plus c there. So let's go ahead and substitute now. The integral from 0 to pi halves of theta squared sine 2 theta d theta equals, when we plug in our limits of integration, we should get negative 1/2 times pi squared over 4 theta squared times the cosine of 2 theta. So that's going to give us times negative 1 plus 0 plus 1/4 minus 0 plus 0 plus 1/4 times 1. Yeah, and that's for our zeros here. That goes to 0, that goes to 0, and then we have a 1/4, cosine of 0 is 1. So let's go ahead and simplify. Here we get pi squared over 8 minus 1/4 minus 1/4, which is simply pi squared over 8 minus 4/8, which is pi squared minus 4 over 8. Final answer. Thank you.